All right, when learning certain skills such as typing or swimming, you often assume that there's a maximum skill attainable. So we're going to call that M. And the rate of improvement is proportional to the difference between what has been achieved, Y, and the maximum attainable, M. So mathematically, dy dt equals k times m minus y, where the y of 0 is equal to 0. So you have none. Now, we solve this type of problem with the same technique we use to obtain the exponential growth law. First, we have to multiply both sides of the equation by 1 over m minus y. That way we can get rid of it and we're solving for our k. So then we end up with this. Then we go over to the next page and we integrate each side with respect to the t. And so when we do that, we work our way down, and we've done this before. Now here in this case, what we're going to do is we're going to say, well, let's let this piece equal u. And then we can say, well, du is equal to what? Well, that's just going to be a minus dy, because that's going to be a minus 1 and then dy. And so that's going to be equal to minus dy dt dt. And so what we get is a minus integral of 1 over u du equals the integral of k dt. Well, we know that that's going to be ln of absolute value of u, and then we have the negative out in front. And that's just going to be k times t plus c. And we go and back substitute our m minus y back in. So we get minus m minus y. Now, what do we know about that? It has to be greater than 0, because we said over here, or we should have said over here, that that was going to be greater than 0 for u. And so that means we can drop our absolute values, what it means. And so now we multiply both sides by the negative here to get rid of it. And so we have the negatives here and here instead. And then what we need to do is we need to take e to this and e to that. And when we take e to that, we just get m minus y. E to that, we get this. And remember, before we could split that up into e to the minus c, e to the minus kt. And they only put the c first. That's because the kt is really the part that we're really interested in. Because remember, if we have PERT, e to the rt is the last part, and so that p was first. And so that's what we're going to kind of end up doing here, I think, is we're going to start solving and try to figure out what that c is. Solving for y, we take everything to the other side, and then we're changing the signs, of course, so that becomes negative. That one becomes positive, that one becomes negative. And now, when we plug in 0, 0, what do we get? Well, that basically goes, that's going to be a 1. That's going to be e to the minus c, and then minus the m. And so we get m is equal to e to the negative c. And so in our final solution, we end up having, we can plug that back in to our original part over here as that m. So we have m minus m times e to the minus k. And depending on how you want to look at it, you can either keep it like this, or you can factor out the m and then have the 1 minus e to the minus kt. So some people want to do that because what might be happening, you might actually have to integrate again or something. And then if you integrate that with the split apart, it's easier. Whereas if you have it combined, it's going to be harder. All right, so that's going to be what we're going to be using to do problems. So let's look at an example then. So problem 4 says, look at our match problem 4 looks at problem 4. So it says, for a particular person learning to swim, the distance y in feet that the person is able to swim in 1 minute after t hours of practice is given by that equation. Okay. Now, that's our example 4. What is the rate of improvement to 2 decimal places after 50 hours of practice? All right. Well, if that's our y, what we need to do, we have to think about what that is. That's going to be what? That's the person able to swim after. That's how far they can go. So what we need to do is we need to figure out and take the derivative. We need a rate of change. And so the rate of change, we need to find what dy dt is. And dy dt, or we can just call it y prime of t if we want to, is going to be what? Well, this case, let's simplify. And that's going to be 50 minus 50 e to the minus 0.04 t. And so the derivative of that's just 0. The derivative of that's going to be a minus 50 times. Then we have minus 0.04. And then it's going to be e to the minus 0.04 t. And so 50 times that's going to be 2. And it's going to be positive. That's going to be e to the minus 0.04 t. So that's y prime of t. So that's going to be our rate of change. Now they want the rate of change after 50 hours. So now we need to find y prime of 50. So we need e to the negative what? 2 and then times 2. And if we plug that in, looks like we get how many decimal places? 2 decimal places. So that rounds to 0.27 feet per hour of practice. Okay, because it says that's how far you can swim a minute after T hours of practice. So we're gonna swim 0.27 feet per hour of extra practice after hour per hour of practice at 50 hours of practice. Now, if we have it at a smaller number, guess what? That's going to probably be a bigger number or something, and so we'd have it's going to be gaining faster at the beginning, but it's going to get slower as we go through the time. All right, so let's stop there and we'll come back for some more.